When dealing with plastic water pipes, the rules for bonding sinks and faucets change. Bonding, in the context of electrical safety within plumbing systems, aims to create a low impedance path for fault currents. This path helps to ensure that if a live wire comes into contact with a metallic part of the plumbing system, the fault current will quickly trip a circuit breaker or ground fault circuit interrupter, or GFCI, protecting people from electric shock. The necessity of bonding hinges on the presence of metallic components within the plumbing. If your entire water pipe system is constructed from plastic, bonding the sinks and faucets is generally not required. Plastic, being a non-conductive material, does not provide a pathway for electrical current. Consequently, there is no risk of a metallic pipe becoming energized and posing a shock hazard. However, if there are any metal components in the plumbing system, such as metal pipes, metal fittings, or metal faucets, bonding becomes essential. Even a short section of metal pipe can introduce a potential shock hazard. In such cases, all metal parts of the plumbing system must be bonded together and connected to the electrical grounding system. The purpose of this bonding is to ensure that all metallic parts are at the same electrical potential. This minimizes the risk of a voltage difference between different metallic parts, which could create a shock hazard if someone touches two parts simultaneously. The bonding conductor, typically a copper wire, must be sized appropriately for the electrical system's overcurrent protection. The National Electrical Code, or NEC, provides specific guidelines on the size of bonding conductors based on the size of the service entrance conductors or the overcurrent protection device. The connection of the bonding conductor to the metal parts of the plumbing system must be made with approved bonding clamps or lugs. These connectors are designed to provide a secure and reliable electrical connection. It's important to note that the absence of bonding in a system with metallic plumbing components can create a dangerous situation. If a live wire comes into contact with an unbonded metal pipe, the pipe can become energized. Anyone who then touches the energized pipe and a grounded object could receive a severe electric shock. Ground fault circuit interrupters, or GFCIs, offer an additional layer of protection. GFCIs are designed to detect small imbalances in current flow, which can indicate a ground fault. When a ground fault is detected, the GFCI quickly trips the circuit, cutting off the power and preventing electric shock. GFCIs are often required in areas where water is present, such as bathrooms, kitchens, and laundry rooms. They can provide protection even if the plumbing system is not properly bonded, but they should not be considered a substitute for proper bonding. In summary, the decision to bond sinks and faucets depends on the materials used in the plumbing system. If the system is entirely plastic, bonding is typically not required. However, if there are any metal components, bonding is essential to ensure electrical safety. Always consult with a qualified electrician or plumbing professional to determine the specific bonding requirements for your situation and to ensure that all work is performed in accordance with the National Electrical Code and local regulations. Ignoring these safety measures can result in grave danger. The NEC provides detailed requirements for grounding and bonding electrical systems to ensure safety and minimize the risk of electrical shock. Section 250.4 1 of the 2023 NEC, for example, requires that normally non-current carrying metal parts of electrical equipment be connected to the equipment grounding conductor. This includes metal enclosures, raceways, and other metal parts that could become energized in the event of a fault. The equipment grounding conductor provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device and clear the fault quickly. Section 250.104 of the NEC addresses the bonding of metal water piping systems. It requires that metal water piping systems that are likely to become energized be bonded to the equipment grounding conductor. This bonding helps to ensure that the metal water piping system is at the same electrical potential as the other grounded metal parts in the building, which reduces the risk of electric shock. The size of the bonding conductor is determined by Section 250.66 of the NEC, which provides a table for sizing grounding electrode conductors based on the size of the service entrance conductors. The bonding conductor must be sized no smaller than specified in this table. The connection of the bonding conductor to the metal water piping system must be made with an approved bonding clamp or lug. The connection must be accessible and made in a location where it is protected from physical damage. Section 250.50 of the NEC requires that all grounding electrodes that are present at a building or structure be bonded together to form a grounding electrode system. This includes metal water pipes, metal building frames, and concrete encased electrodes. Bonding these electrodes together helps to ensure that all parts of the grounding system are at the same electrical potential, which reduces the risk of voltage differences and electric shock. Grounding and bonding are essential for electrical safety. They help to protect people from electric shock by providing a low impedance path for fault current to return to the source. This causes the overcurrent protection device to trip quickly, which cuts off the power and prevents electric shock. When working with electrical systems, it is important to follow the requirements of the NEC and local regulations. This will help to ensure that the electrical system is safe and reliable. Here are some additional details to consider. Firstly, local codes can sometimes be more strict than the NEC. Always check local regulations to ensure compliance. Secondly, even with plastic pipes, a metal faucet can introduce the need for bonding. The faucet body can become energized if a wiring fault occurs nearby. Thirdly, consider the possibility of future changes. If metal pipes are added later, the bonding will need to be updated accordingly. Fourthly, proper bonding helps prevent corrosion of metal pipes. Stray electrical currents can accelerate corrosion, so bonding helps equalize potentials. Fifthly, it is important to visually inspect all bonding connections periodically. Look for signs of corrosion or damage that could compromise the connection. Sixthly, use appropriate tools for making bonding connections. Crimping tools and torque wrenches ensure proper connections. Seventhly, when in doubt, consult with a qualified electrician. They can assess the specific situation and provide guidance on proper bonding techniques. Eighthly, ensure that the bonding conductor is protected from physical damage. Run it through conduit or use other protective measures. Ninthly, label all bonding connections clearly. This will help with future maintenance and inspections. Tenthly, document all bonding connections in the electrical system drawings. This will provide a record of the bonding system for future reference. And consider using exothermic welding for bonding connections in critical applications. This provides a permanent and reliable connection. It's crucial to understand that the absence of metallic components does not automatically eliminate all electrical hazards. Other factors, such as improper wiring or damaged appliances, can still create shock risks. Therefore, it's essential to maintain a safe electrical environment regardless of the plumbing materials used. Moreover, the definition of bonding in this context is specific to electrical safety. It differs from other types of bonding, such as adhesive bonding or chemical bonding. Understanding the specific meaning of bonding in the electrical context is crucial for ensuring proper installation and maintenance. The National Electrical Code, or NEC, Article 100 provides definitions for various electrical terms, including bonding and grounding. Consulting these definitions can help clarify the specific meaning of these terms in the context of electrical installations. It is imperative to remember that electrical work should only be performed by qualified individuals. Attempting electrical work without proper training and experience can be dangerous and potentially life-threatening. Always hire a licensed electrician to perform any electrical work in your home or business. The electrician will be familiar with the NEC and local regulations and will be able to ensure that the work is performed safely and correctly. Here's a breakdown of common scenarios and how bonding applies. Firstly, all plastic pipes and plastic faucets, no bonding is needed. Secondly, plastic pipes and metal faucets, bonding may be required, depending on local codes. Thirdly, metal pipes and metal faucets, bonding is required. Fourthly, plastic pipes and metal fittings, bonding is required for the metal fittings. Furthermore, consider the size of the metal component. A small metal fitting may not require bonding, while a larger metal pipe definitely will. Also, the location of the metal component is important. A metal pipe near a water source may require more stringent bonding than a pipe in a dry location. The type of metal used in the plumbing system can also affect bonding requirements. Some metals are more conductive than others and may require larger bonding conductors. The age of the plumbing system can also be a factor. Older systems may have deteriorated bonding connections that need to be replaced. Remember that the purpose of bonding is to create a low impedance path for fault current. This path helps to trip the overcurrent protection device and prevent electric shock. The impedance of the bonding conductor must be low enough to allow sufficient fault current to flow. The length of the bonding conductor should be as short as possible. A longer conductor will have higher impedance and may not provide adequate protection. The bonding conductor should be installed in a manner that protects it from physical damage. The conductor should be routed away from sharp edges and other potential hazards. The bonding conductor should be securely connected to the metal parts of the plumbing system. The connection should be made with approved bonding clamps or lugs. The bonding conductor should be inspected periodically for signs of corrosion or damage. Any damaged conductor should be replaced immediately. The bonding conductor should be sized according to the requirements of the NEC. The size of the conductor depends on the size of the service entrance conductors or the overcurrent protection device. The bonding conductor should be made of copper or another approved material. The conductor should be insulated to protect it from corrosion and physical damage. If you are unsure about the bonding requirements for your plumbing system, consult with a qualified electrician. The electrician will be able to assess the specific situation and provide guidance on proper bonding techniques. Never attempt to perform electrical work if you are not qualified. Electrical work can be dangerous and should only be performed by licensed professionals. Remember that safety is always the top priority when working with electrical systems. Take the time to understand the bonding requirements and follow the instructions carefully. This will help to protect you and your family from electric shock. So, to reiterate, if you have a plumbing system that is entirely plastic, meaning all the pipes and fittings are plastic, then you typically do not need to bond the sinks and faucets. However, if there is any metal in the system, whether it's a metal pipe, a metal fitting, or a metal faucet, then bonding is generally required to ensure electrical safety. Always consult with a qualified electrician or plumbing professional to determine the specific bonding requirements for your situation.